Hi, I'm Chris. I'm working at the Distributed Robotics Lab in Seasail with Robert Catchman and Daniela Russ. Basically, the lab's developed a soft robotic fish. Right now, the mechanism is there. We have a hydraulically powered soft-tailed fish. There's been a lot of interest in soft robotic fish in the past because the flapping tail motion is actually very efficient underwater compared to a traditional propeller on a submarine. You get more efficiency and just power use and higher maneuverability, and a fish can turn in a fraction of its body length, whereas a submarine has to slow down and turn into this big arc. So fish are much better in complex underwater environments. There's been a lot of research and interest in exploiting that mechanism in robotics. One thing that makes our fish novel is the hydraulic tail, as opposed to a pneumatic tail, which is a more slightly easier to implement, but also not as you don't get as much duration because you run out of air, for example. It's a few other problems with the buoyancy control as you're losing air. So hydraulic tail is ultimately probably a better system, which is why we try to use it. What I'm working on is the software and the visual servoing and things like that. We're trying to build the autonomy of the fish. So far, all the existing robotic fish have been just teleoperated. So they're just stupid fish that you have to drive around like a remote control car. We want to make ours autonomous. So our software right now, the dream is to get it to lay a foundation that's expandable and modular. So it's easy to add on different layers of autonomy and different modes of moving. So for example, we could have pre-programmed paths or some kind of computer vision control motion. You can add in other things as you go. We want to make it very easy to add on different behaviors. That's kind of what I'm working on at the moment. Hopefully within the next few months, the first level of autonomy will be this visual servoing, where say you're following some brightly colored target like a life jacket. You can use computer vision with a front-mounted camera on the fish to pinpoint where that target is in the scene. And if you assume that here that your direction of motion is straight into the center, then you want to correct that so it's pointing at the target. So you just calculate an offset, input that into your swim controller, adjust here up and to the left, and that way you stay pointed at the target. There's actually a lot of subtleties with the control you have to deal with, how fast you're going to make sure you don't pass the target or lose sight of it. Things like that I think will be interesting to explore as we go with that. And then once we have that, we want to build on more sophisticated navigation techniques. Underwater localization, for example, with acoustic positioning, we could use for waypoint following, things like that. So there's really a lot of potential with this platform. We're just trying to build a platform that's easily expandable and can be used for further research on just fish control, fish movement, and underwater controls.